Max. Today let's solve the valid parenthesis. Given a string contains just a character. Okay. This character and determine if the input string is valid. And input string is valid if the open bracket must be closed by the same type of brackets. Open brackets must be closed in the correct order. Okay. So these are the examples. So to solve this question, we need to have a stake to remember the order of the open parentheses. So we need a stack to remember the open parentheses, and we need a mapping to map the closed pair into the open pair. Okay. So something like this: close to open, close to open, close to open, and then the closed pair to open pair. And we can start using some example, like example 2. So for example, we just loop through this string. When we encounter the open pair, we just put into the stack, push to the stack. And when we encounter the closed pair, we have to pop from the stack, pop out from the stack. Okay. And then we just use the closed pair to map into the open pair. Right? For example, this one is the closed parenthesis. We just map to open parenthesis and check whether or not it's the same from the one we pop from the stack. And it's the same, then we just continue. Okay. This part, open bracket, close bracket, we just map to open bracket, right? And we also remember to pop from the stack, and it's the same, so we just continue. Open brace, put to the stack. Close brace, so we have to pop first, pop from the stack, and to check whether or not this is mapped to the correct pair. So this is the close brace, so we map to open brace, and it's the same, so this one is the true. And in the end, we need to remember to check the state if we have redundant open pairs. We can use example 4 as another example. So let me delete this first. So we have open pair, put to the stack. We have an open pair, put to stack. Okay, we have closed pair, then we just pop from the stack. Okay. And we use this closed pair to map to open pair, right? And to check whether or not it's the same. And it's not the same, so we just return false. So that's the basic idea. Let's see how to write the code. So as I said, we need a stack. To store the character and store the open pairs. Okay. And we need a mapping to map from the closed pair to open pair. Sorry. And then brace. Okay. And we just use loop through the character, loop through the string. Okay, range string. First, we have to check whether or not it's the open bracket or the closed pair, right? So we just map, put the character into the map, and then we will have OK and maybe open what's this? Pair. Okay. And then if it's not okay, it's not okay, it means that we can, it's not the open pair, it's the closed pair. So it's open pair. Now okay, it's the open pair. Then we just append or push to the stake. Else means that is a closed pair. It's an open pair. It's a closed pair. Then first we have to pop from the stake, right, to get a lattice open pair. So we have to check whether or not we have something to pop. So if length of the stake is equals to 0, means something wrong. We have to return false. Otherwise, we just pop from the stake. Open pair. From the stake. There's the stake. And we also need to remember in Go we have to do this. We just remove the lattice item. Okay, and then we just compare. This part is pop from the stake, and then we just have to compare. If the pair is not equal to the open pair, we just return false. And last, we have to check whether or not our stake is 0. If our stake has the redundant open bracket. Let's see what happened. Okay, yeah, that's it. Sorry. And because we loop through the string one by one, so the time complexity is O(n), and we have a mapping here. So the space complexity, I would say, is fixed, right? We just, oh no, we have a stake. We have stake to store the open bracket, open pairs. So it's not consistent. So it's not constant. So it's all of n. Space complexity is all of n. Let's see the result. Okay. Yeah, that's it. And thank you for watching.